Hello, everyone, and welcome to Quanta. This is going to be our first talk called Probability and Statistics as a way to have more fun in life. So, my name is Arsenii Nikolaiev, short Senya. That is how you can address me in the chat or in the email. And let's get started.
Yeah. Hello, I'm here. For this talk, I will not assume any kind of knowledge from you about what is probability, what is exactly statistics, what is data analysis. Like any kind of experience is not needed. All I want from you is kind of understand what is probable, what is 90% chance, and know, or at least have like just have any kind of news maybe in the back of your head, just any kind of things that you probably watched on the TV that starts with recent study shows that blah blah blah. That is enough. So this is more of a popular science talk. Things like mathematical expectation, what is exactly probability, maybe measured, etc. So these mathematical details are left for courses that we aim to start later on. And just so you know, so I'm gonna start talking about whatever the talk is about, but later on, closer to the end, I will also say a few words about what is what is it, Quanta, what are we up to, why Quanta, etc. Okay, let's go. Okay, I hope you see the next slide called introduction. So yeah, thanks to, well, if first of all, we put all the jokes aside, all the fun, as I put it in the title of the talk, thanks to this part of math that is called probability and statistics, we can actually properly test many our hypotheses. In particular, we can now properly test our medicine. So it's not, well, maybe you don't exactly know what, how exactly medicine is tested, but what you should trust me with is that it's not just take a pill, give it to 100 people and hope that, it works. It is a bit more complicated and involves mathematical kind of analysis. Also, thanks to this part of math, we can obtain important information from loads of data, check if the patterns that we think are there are actually patterns and not just, random things that we see that have no actual explanation or no mathematical support. And finally, we could even predict the future. In particular, that is how a number of people make loads of money. And that is what we might be talking about next time. Yeah, but far not always this amazing tool, by the tool I mean the probability and statistics, is used properly. Sadly, quite often it is used to share and produce junk. And sometimes this junk, or the way it is obtained, is actually just quite funny. So thus properly diving in the world of probability and stats will not only defend you from being misguided or being lied to and being sold as junk to you, but will also hopefully provide you with more occasions to just smile, like how funny some things that are shared with millions are. Just an example, if you listen, just pick the news about the coffee, for example. It's one of the trillions of topics, right? You can do food topics, sports, what is good, what is bad, what we expect of the future, like many things that can be regarded as kind of statistics or research shows, etc. Research can be about anything, or studies can be about anything. But if you just a few months about what is up with coffee, you might get the feeling that it is something that can actually kill you or save you from anything. And these are not random magazines. These are not gossips from your friend from floor below. It is actually newspapers like Forbes, Fox 2 Now, Science.mike, which is I think a website, but I'm not sure. New York Post. So these are rather reputable magazines. So you kind of want to believe them. And well, according to them, drinking more coffee may reverse your liver damage, which means it's good for your liver. So drinking coffee may cut your risk of developing endometrial cancer. So it kind of helps you with cancer. Also, coffee consumption may help prevent colon cancer. So again, it should kind of help you with cancer or something. And coffee consumption in coffee consumption may, as it's written in the forest, may raise miscarriage risk. So something to give birth. Once again, it's either good, very good, or very bad, can treat cancer. crazy thing this coffee is, and this is thanks to all the studies or whatever news call study is. And well, there are many ways why some of these studies, and I just showed you 4 about coffee during a few months, so multiply it by 100 to get a number of studies about coffee during the few months, maybe a few years. So a few hundred studies about coffee. Definitely something is not right. And yes, not all of them are correct. And one of the ways to produce a study that is actually wrong and yet you do everything honestly, kind of not just lie, just say like something that is wrong, you have no background and make up stuff, is to have way too small of a number of people involved. So, for example, imagine that I ask, I know, somebody from the talk today, somebody like Anton Gavrilyuk, do you like cucumbers? And he tells me yes, and I say yeah, and me as well. So it is 100% of people between like among me and him that like cucumbers, and so I can conclude that everybody in the world likes them. So because it's 100% chance, so I can write a paper saying, well, I tested it on a bunch of people, 100% chance, so everybody does, so we must produce more of cucumbers, blah, blah, blah. And then the media picks it up and like, then you can read about it on BBC, The Guardian, on some Ukrainian news like Ukrainska Pravda, etc. And yeah, it's kind of ridiculous, but sadly, this is not a joke. So the 2 pictures here are 2 studies, just 2. There are many more examples, and we'll cover them in the future courses as well, just showing you how many of them are. And one of the study involves 5 men and 11 women. The thing on the left, as you can see, and the thing on the right involves a small trial of 12 men. So the first one concludes that there is no proof that chocolate consumption affects BMI. In simpler words, it means that chocolate does not make you gain weight, which it does actually. Sorry, but yeah, the study on the right says that you should drink water before you drive, otherwise kind of bad things happen. So these are 2 studies, and it doesn't even matter what these studies are about. What matters is it is a study that involves 16 people, one, and 12 people, another. Like this talk here, like I'm presenting this to 38 people online right now. This is already more people than these 2 studies have combined. And somebody, well, decided it's kind of good enough to have, this is kind of good enough to publish, share with the world, etc. And not only this person who decided to share this, the scientist decided that it's kind of good enough. Well, at least this scientist shared the information that, there was so this many people involved. But news decided to cover the first bit very much because it sounds amazing, right? And the media picked it up immediately and spread it like white wildfire. Like you see, scientists say eating chocolate can help you lose weight. Excellent news, chocolate help you lose weight, and something a little bit kind of like the world gone crazy. Eating chocolate can help you lose weight, right? It's 3 different markets, and there are many more. And the second study also went not as viral, but still, Fox News decided to share and say that dehydration danger, driving dehydrated, same as driving drunk. That is the interpretation, let's say. Fox News is a rather big thing, as some maybe people who know about South America know, and other newspapers are also not that small. But yeah, and they didn't check anything. They just decided to share it. Yeah, why not? Study involves 12 people. Let's go spread it like for millions of people. Yeah, and the next step, yeah. So this was just an example of some kind of mistake that we, like some scientists and we people make when talking or spreading or sharing something about statistical studies or whatever. Now I'm going to go a little bit more mathematical into what are the other kind of issues there are in the world of statistics and sharing the articles about some whatever it is. So even if you do a study properly, which most of the studies at least try to, even if it has a lot of people involved, there's always a small chance that the results that you obtained, that you think are cool in some way, are not actually cool, but you're kind of just lucky to obtain them. It's like, imagine you toss a coin that is actually symmetric, fair, etc., and then you're just lucky to get 5 tails in a row. It happens sometimes, right? And then, so what can you say? You can say that, well, since why 5 times out of 5 times it was tails, it means that the coin is not good. It's not symmetric, anything. It has 100% chance of showing tails, which it might not. And later on, you might see 5 heads, so it will balance it out. Yeah, but anyway, there is always this percentage of being lucky. And well, scientists know about it. And if your scientific research, your study, whatever, says that or shows that this percentage of getting just lucky in your study is less than 5%, then you can publish. So once again, every study is imperfect. There's always a chance of being lucky. And if this chance of being lucky is less than 5%, we kind of say, yeah, it's fine. It's okay to be still published. And we say that these results are statistically significant. So that is what you can probably hear in the news, and maybe some of you will now know what it means. In particular, this means that out of every 100 studies, approximately 5 are actually wrong. Not deliberately made wrong, not because somebody decided to lie, but because it is just luck. Just somebody decided to test something and he or she got lucky. So 5 out of 100 studies are wrong just because of that. In reality, the percentage of wrong studies is sadly much more. It can be, there are different estimates because, well, you don't know which exactly is correct or which not. You need to go through millions of them. But the estimates are like 40% of the studies are actually not true, sadly. And later on, maybe in some talk or some other person will explain you why. But yeah, at least 5% are definitely not good enough. So now I'm gonna, this slide is the most mathematical slide from this presentation, so just be ready. It is not difficult, and there are some students here who definitely catch it quite quickly, but just give you some, one more kind of important definition, and also, yeah, show you how kind of one of the tricks that people can use to produce a kind of a funny junk study. So that chance of luck that I talked about before, that we want to be less than 5% to publish, to share with the world, is what is usually referred to as p-value. Well, the exact definition is actually might be a bit different depending on the situation, blah, 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 but that is kind of approximately what it is. So this p-value is a fine measure of how credible the study is, because, well, if you know, kind of, it is very unlikely that what you obtained is just luck, then you can say that, well, it's probably not luck. But it is definitely not perfect. For example, it doesn't, say anything about how many people are involved. So, if you test things on 2 people, like me and Anton, both like cucumbers, so everybody in the world does, it's a 100% chance. Yeah, still, even if the p-value is 5% or something, still, I mean, 2 people, I mean, it's not serious. But so it is imperfect. And there's also, even if you toss aside the how many people are involved part, you can do a trick with this p-value, which is referred to as p-hacking. So imagine that you want to produce some cool study about chocolate, okay? Just you want to share some cool news about what you know um, is. For example, imagine that you want to share some cool study about chocolate. But well, you don't know what exactly cool to share, but you know that if you decide to check that if chocolate improves health and you test it on people, then there is like kind of 5% chance that you'll just get lucky and you will get this cool results that everybody will pick up and share, and like the BBC will pick it up. Yeah, and you'll even have some mathematical proof for this. So there's like only 5% chance approximately that it will be the case. You'll just get lucky. Imagine that is the case. Then, so how do you get the study. I mean, you can't just run the study and hope that with 5% chance you'll get lucky. Right? 5% is not much. 5% you might, you might not get lucky, and then well, you'll get nothing. So what do you do? What you can do is you take a bunch of people and you keep track of a few features while giving them chocolate. For example, you check if you keep track of their health, uh, keep track of their heart rate, how much they weigh, whether how strong they are, how fast they think. I know you can even keep track of IQ, etc. So, and imagine you keep track of 20 things at the same time while giving chocolate to some people. And for each of these things, for each of these features, let them call it that, there is 5% chance that, well, you'll get unexpected cool results. That will be just kind of luck, but they will still be technically statistically significant. So then, in order to get at least something cool, the chance of getting at least something cool will be 1 minus 0.95 to the power of 20. That is because it's 100% chance minus every single study was good. Was good, by that I mean was not lucky and didn't give you anything, unexpected. So it will be 1 minus 0.95 being a good study for the first feature, 0.95 for the second feature, etc. So it will be 1 minus 0.95 times 0.95, blah, blah, blah. And that is approximately 64%. So this 0.64. So once again, there is around 64% chance that if you do organize your study like that about chocolate, you'll get at least one feature that will give you unexpected results that will be just luck. And well, you don't really care what exactly that is, right? It can be, lose weight, like in the previous study before. It can be, you get stronger. It will be at least something, and you'll be able to publish. And that is the most important, right? That's what the media wants. They want a cool story, and that's what probably even you as a scientist may be forced to have, because some, universities, some companies force the scientists to have something cool, because otherwise they can think the scientist is just stupid and can't produce anything nice. Because I mean, I've never heard about the study saying that chocolate is nothing special when it comes to how fast you think, like how fast you grow, right? I mean, what is this study? Chocolate is nothing special. Nobody will read about it. So you only get to know about the studies that are somehow interesting, right? So you need people to produce that, and so that is kind of a way to organize things so that you are much more likely to produce that. And well, it is a theoretical thing I was just talking about, but someone actually did it. So the example from before, the example about yeah, here about chocolate and yeah, chocolate loses weight. That's exactly how that study was organized. There were a bunch of features being kept track at the same they were keeping track at the same time of few features like heart rate, weight, etc. And well, it just happened that the person got lucky, and the sample, so a bunch of people that the scientist had, they did kind of lose weight on average. And so, yeah, he published, and it was statistically significant result, even though it's of course not true, whatever the conclusion is. So yeah, and just to stress you, just to stress one more time how crazy it is to publish a result about like 12 people involved and check like whether dehydration is actually that bad before driving, or like is it the same as being drunk? Or for example, this study about chocolate, I think what is it involves 16 people. 16 people. We have 38 people here, so let's just let me just ask you some questions. One of them I'll pick some and see what you respond. And then if we get some interesting results, maybe we'll just be able to publish them and say that look, we had 38 people involved, and we got something interesting. And so, well, here we are. Nice study. Please, BBC, spread it like everybody to everyone. So anyway, just let's just do an experiment. So first of all, please raise your hand if you think that math is quite nice. Just raise your hand in Zoom. It is there's a button for this. So yeah, 1, 2, 3. Yeah, it is 32 people. Yeah, it is 32 people out of 38, which is, if we calculate it, it is 84%, approximately 84% of people that among us that think that math is quite nice. Maybe others are kind of asleep already or something, I don't know. But the point is, well, I made the research, kind of asked 38 people, not even 16, and 84% like mathematics. So what my conclusion is, well, everybody, like all around the world, 84% of people likes mathematics. It's the vast majority. Or at least if I want to be a bit more statistically correct or something, I can say, well, 84% plus minus maybe 10%, because maybe somebody clicked my button, maybe saying blah blah, whatever, and then I can try to calculate some kind of p-value, assuming that my hypothesis, the null hypothesis, it's a comment for people who know, is like 50-50, like not like math, I don't know, and then get that, yeah, actually many more people like math than not. The point is, whatever I'm just saying is totally useless, right? It took me 1 minute to produce these results, but sadly, whatever I've just done is actually as good as many of the researchers that you might hear about on the news. In particular, this questionnaire this question that I have just asked is super stupid because, I mean, not stupid, but like super uninformative, because you are at the mathematical talk, right? So right now we are here talking about mathematics, and you came here because there was a mathematical advertisement. So it is kind of clear that many of you, think that math is quite nice, right? So in smarter words, it is my results are clearly biased. So, and I can do a similar questions with the other questions that you see here. So, what do you prefer, white chocolate or black chocolate? Or do you have access to a phone or computer? And well, clearly the last question is also something that is kind of pointless to us because it is clearly biased. I mean, because you are online, right? So it is likely that you have. So it will not tell me anything about the world. The one in the middle might be a little bit more fair. So let's ask. So please raise your hand if if you think that white chocolate is nice. I mean, nice. I mean, maybe, okay, not nice. Okay, let me reformulate. Um, Raise your hand if you prefer white chocolate over black chocolate. 1, 2, 3. Yeah, it's 13 people. Okay, yeah, 13 people. And now please put down your hands. And now please raise your hand if you think that black chocolate is something you prefer more than white chocolate. I mentioned you have only two options, so what would you go with? Okay, 1, 5, 17. So 17 for black, 13 for white. Some other people didn't say anything, maybe just hate chocolate. I don't know. Yeah, but well, we can conclude that black chocolate is something that is more favorable than white chocolate, and for example, create a study about it and send it to a company, and then if the company really doesn't want to, really wants their business to go bad in the sense of kind of uninformative, that don't have any mathematics behind it, then well, accept our study. Black chocolate is 17 divided by 13, which is it may be like 30% more like people like more than the white chocolate. So the companies who produce chocolate should probably think about it when thinking which chocolate to produce, right? But anyway, all these three questions are like they are fine questions by themselves, but me asking you and collecting information, presenting this later as a paper and saying the study was statistically significant, blah blah blah, is ridiculous. But some media does it. And as a final test, let's just check if, let's just check if you can see into the future. It is crazy, but the examples that I'm giving you are not even something that I made up, not something that I just made up to show you that it is all crazy. It is actually what people did. It is actually what somebody published, and there's actually Yeah, there was actual research from Cornell University about it. You can Google. It's called Cornell University evidence of people seeing into the future or something. And then actually, the media started spreading it like white wildfire again. They start saying something like 6 cents proven. So yeah, let me stop screen sharing, and then yeah, I'll just quickly do this. Do experiment, and we'll maybe I don't know. Once again, I'm doing this honestly with you. I don't know, like you're not people that I organized to come here deliberately to produce something and then spread it all around. You're kind of random people. It's a random question, so let's see if we can prove anything. Like if let's test if people can read minds through a computer. So I'm gonna write a number, and so just to make sure that that everything is done honestly. Okay, so I'm gonna write a number on this card, and then it will be one or two, one of the two numbers, and then I will ask you to guess, what is this number, and thus will decide to check if actually people can see, through the screen, or like predict the future, or see into the future. Let's just check it, and yeah, maybe people can see into the future. Why not? Why not? Yeah. So okay, I wrote a number here, and now if you think this number is 1, please raise your hand. Okay, so yeah, just raise your hand once again if you think this number is 1. Okay, so let's say it is 16 people. Yeah, and let's check. Okay, who thinks now? Please raise your hand if you think that this number is 2, because probably some people are offline or something, or just can't press. 19, 14. So 17 people think 17 was, I think. Yeah, 17 people think it's 1. 13, yeah, and 14 people think it's 2. Okay, now let me reveal the number. It is 1. I don't know if you see it. I didn't cheat or anything. There's no point in me cheating. I mean, this. Yeah, so I don't know if you see it, but that is in purple written it is 1. So apparently you can see into the future, right? Or see not into the future. Yeah, basically you can see into the future, right? Because you didn't know what I'm gonna show, but or maybe you can read my mind. I don't know. I need to think what to publish, to be fair, but yeah, like I basically ran a test on 31 people, because 17 plus 14 is 31, right? And 17 people guessed my number. So, well, 17 out of 31, it is not just more than 50%. It's kind of much more than 50%. Actually, it is actually, it's not even a joke. There was a study, a real study by Cornell University, saying that yeah, people can see into the future, and as a statistically significant proof of this, they shared a study where 53% of people guessed something. 53. Let's check how much is 17 divided by 31. Once again, you're all random people, right? I'm not kind of doing this. 17 by 31 is 0.4054. So it's 55. So it's even better than the Cornell University study in some sense. So yes, well, we just proved again that we can see into the future quite, it's quite surely the case. Just like that. Once again, this is yeah. So yeah, let's go back to, once I continue sharing the screen, I'll answer the questions closer to them because I'm almost done. Yeah, okay, so back to the presentation. After listening to all this, at least me, maybe some other people might have several whys. And yeah, I'm just putting 2 of them. You might have many more, but 2 important ones are, why don't we get to study those weird examples at school? They're actually also a bit funny. In my opinion, some of them. There are much better ones that will come into the course. Just trust me, there is something that is truly amazing. wouldn't even believe a media would even think about sharing before checking. But anyway, why don't we get to study those weird examples at school and why media quite often makes silly mistakes and publishes some unscientific rubbish? And this is just a tip of the iceberg. Whatever I'm telling you is a tip of the iceberg, right? I'm not going deeply mathematical. I'm not giving you many examples. I haven't even mentioned some kind of corruption. For example, some company like Coca-Cola doing research saying that sugar is amazing, right? Um, and also not some problems that scientists actually might bump into, some more tricks from p-hacking that I mentioned before that actually real scientists that are much more trustworthy people can do. So this also can raise a question of, can we even trust science? I mean, maybe everything is rubbish and we can't trust anything. So a pause here. First of all, the answer to that question is yes. Whatever I was building up this skepticism, and you're right, I was giving you examples, etc. Right, but yes, you must trust science, but you must trust real science that is not just some media sharing a title sounding like crazy in information, but then when you dig in, it turns out that the study involved 5 rats, 2 boars, and 3 people that all kind of didn't even understand what was going on and were answering your questions randomly. You need a proper, real science with a proper kind of analysis, and that's why a number of reputable magazines are actually good because they check it properly, etc. And you can trust those in 99% cases. Yeah, but real science is kind of the best model of the world we currently have. It isn't perfect. There's always a chance of luck, but yes, you do trust real science. That's the best we can do for now. And that's for the questions that are the 2 whys that I mentioned. Well, you might not be able to see the second response, so I'll read it. But the first question actually has a little bit of a sad, clear answer, which is, well, you know, why don't we get to study those weird examples at schools? And that is because, well, why a country would even want a population that is skeptical, has good critical thinking, and is packed with smart people? It is much more difficult to govern these people. I mean, at least that is my explanation to why don't we get to study much more about this, and instead, for example, spend, I don't know, in many schools, spend much more time on integrals, remembering formulas, etc., that we forget immediately after the final exams. And that is what I was just telling you about p-value, etc., right? Is something that kind of can stay with you for a bit longer and there's a clear use in it. Yeah, and as for the second question, why media quite often makes silly mistakes and publishes some unscientific rubbish? Well, because who cares, right? All that media needs is a catchy title, and most people look for an interesting story to read. So trustworthiness is something we like, but do not exactly cherish and pay for as much. So that is why, yeah, we get to hear a lot about unscientific things, sadly. Yeah, but at the same time, it is kind of positive. I mean, it's not positive. It's more like if you have a positive view in life, then you can, kind of smile much more seeing this amazing researches that actually people were working for years, for example, by asking 13 people or 15 or 50 people. It's also a small number. Asking 50 people, producing psychological research, getting a diploma from the university, and then going into being famous or being cited by some big newspaper like the Independent or something. I don't know, maybe not Independent, but some newspaper that likes sharing a lot about the studies. Yeah, so that is kind of it when it comes to the talk itself. Later on, I'll answer your questions. And finally, I want to briefly talk about Quanta. So why Quanta? And well, there are many reasons. The small list of them is here on the slide, so you can quickly read them one by one. I'll also go through them quite quickly. So, as I many times pointed out in this presentation, the school has these many schools, of course, not all. Some schools are very nice, and I'm super grateful that they exist, or some clubs, or some people teaching people separately. But on a general level, Not so much, and actually 99% of schools I think are quite do not really pay that much attention to all of this. And so with Quanta we aim to give you an opportunity to nicely develop critical thinking. That's number one. It's probably one of the most kind of a critically important thing to think critically, like vitally important to think critically, in other words. And that is what we hope to bring with this project. Then we hope that I mean, to be fair, we'll not hope. We'll just show you the amazing applications of probability and statistics, because now, like this century, maybe the past 50 years, it is actually a very hot topic. So if you ever heard about machine learning, artificial intelligence, data analysis, maybe somebody heard from you from trading or finance and making a lot of money. So all of these things require good understanding of probability theory and be good at statistics, data analysis, which is kind of a synonym in some sense, etc. So we want to show you applications of it, give you some tools for being confident with kind of basics math behind all this, so you can later move on to give you more opportunities in life on what to do. And that is what we also want to it will be a part of this educational project. Also, we want to just give you more opportunities to smile. I mean, it is some of the things will be objectively hilarious. Even people who do not know anything about mathematics will still kind of read it, and if they get to know why or how the research was conducted, they'll be like, Yeah, and if you know more, then it will be kind of even more funny for you. Yeah, and as a general thing, just I would like to kind of stress it as a difference to many other clubs. I'm not gonna. So this talk is kind of popular science. It's lecture style. But in the courses that are coming in the beginning of October, we'll notify you later. We will actually do a lot of problem solving. We'll show you applications. We'll make you hopefully smile a few times. We'll show why we answer all the questions and give you some lectures explanations, but will be a lot of problem solving. Like you have a problem, you need to solve, give a solution, and we need to check. We'll check. And that is what will also be a part, like kind of philosophical part of Quanta. And we'll organize everything correspondingly so that like online you can communicate with us during the week, etc. So that will be also part of Quanta. Yeah, and so thus, as one of the conclusions, one of the things that you'll hopefully get from all of that after you finish Quanta is that we'll hopefully, actually again, why do I use the word hopefully again? We will teach you the necessary skills for a number of important things, and in particular, will very likely help those who will end up in science to actually do things with higher probability more properly. Let's put it this way, because kind of some part depends on you, how you do problem solving, etc. How hardworking you are, but we are gonna teach you the necessary skills that are actually necessary. Once again, I'm not using the necessary just for fun here. The skills that you will actually very likely need if you do end up in science or even psychology, where you need statistics as well, or biology, where you need statistics as well for testing medicine, for example, or something. So yeah, that is a list of things that we want to bring with Quanta. Everything will be happening in a nice 2D virtual world. It is something I'll go into more details maybe on Facebook. I will write about it because it is much nicer than just a Zoom. We'll not be doing just lectures with me talking and listening, because I think after some time it gets quite boring. No offense to any of the lectures, but still, we'll try to make it much more interactive. So it will be wrapped in an interactive 2D virtual world. We'll provide, teach you necessary skills, show you amazing applications, and we will start from zero. So that will not really assume anything from you, because we can't really assume anything from you thanks to the main school's curriculum. But it's not bad in any way. We'll just go from zero and get you to a reasonable level, whatever a reasonable level means. Thank you for thank you for your attention. Yeah, I think that is pretty much it. So thank you for your attention. Whew. And now it is time for your questions. Anything about Quanta, about probability or statistics, about life, I'm here. Please ask your questions. Thank you.